Hey everybody, this is Larry. This is me going over Q2 of the weekly contest 441 closest Leetcode element queries. I don't know why I said it so awkwardly. But yeah, this one, the key thing about it is just keeping track of all the indexes, right? So I think if you are able to kind of keep track of all the indexes, you should be able to do this. There are a couple of ways that you can think about doing this. I think one kind of fun way to do this, actually, with a better complexity, is going to be with a linked list. I don't have. I'm not gonna. I don't have that solution because I didn't write that during the virtual contest, but we'll go over it next. But the way that I did it is just with binary search. So here, so we have a lookup of the list, right? So for every item X, we just keep track of the indexes. And then now for each query, well, first, if there's only one element, then we just, we set that as -1 and we're good. Otherwise, we find the index in which the Q is, right? So because the Q we get is the index, so num sub Q is the number, and then F of num sub Q is the array containing all the indexes, right? So we get the index of inside this F array, F sub num sub Q array, and then it's just either the next element or the previous element wrapped around, right, on this F array. And that's it. And all this, and I convert this to a C function where you have index A and index B in a circular array. Then it's either the closest distance between them, the next one where you wrap around the A, and then the other one where you wrap around the B. And that's basically the how I get this formula. You could kind of work this out in case you are curious. A minus B I think is straightforward, but if you kind of think about this one, is just that if B is on the left side, A is on the B side, all the way to the right, and maybe the end of the array is here, then you could think about, although this is the other way. If you have something like this, then you can think about moving A to this spot, which is going to be A plus N, and that's how you have this thing. This one is similar, right? It's just basically if you have A and B, so then here you want to move B to here, but the way that I wrote absolute value is that A minus B plus this, so that's why this is two negatives, and that's basically how I did this. And this is going to be this is linear O of N. In terms of Q, this is O of Q number of queries. Each query has, of course, a binary search on the N, so this is going to be Q log N, right? So this is actually in total, this is going to be O of N plus Q log N. However, like I said, you can use a linked list, and if you do use a linked list, you're able to reduce it with get rid of log N to get it to O of Q on the query side. And the way you do that is by, if you're able to look up and mapping to an index to a node, and then given that node, you just look at the previous node and the right node, and that will give you and that will give you the answer. That will give you, that thing as well. But you can actually do an additional thing, I suppose, which is that, maybe you could even, that is one way to do it. But if you want to just get rid of this search, you can also pre-process everything, right, for additional space. So maybe you have something like this where, maybe like I don't know, naming things is tough. So like maybe some F index or something like this, right, is you go to none times N, where N is the number of nums, right? Now that I think about it, but yeah, if you write that, then now num sub F of index is just equal to the index that we just added here. So you can have this as F of X. The length of that would be the last element. No, -1, I think, right? Yeah, would be the array here. Then now this means that this is just gonna be num sub F of Q, right? And that's it. Yeah, I think this is right, unless I'm off by 1. Looks okay. Let's give it a quick submit. Yeah. So here, then now, as you can see, everything is now linear, and this is N plus Q. I mean, it's not quite it's not quite a linked list, but I guess it's the same principal idea of just keeping track of this lookup in O of 1. So yeah, so now you have a fully linear n plus q solution, and that's all I have for this one. Let me know what you think. Thanks for watching, and yeah, you could watch me suffer live during the contest next. It's good that I didn't do the contest anyway. I don't know why I'm so bad at this. Okay, fine. So that's 202. Let me actually hit the lap button. Actually, I guess I could have just done the lap button. 204 according to that by the time I clicked on the button. But alright, this is like a traditional speed run where I'm clicking on everything manually. Alright, anyway, closest equal element correct. Now I got 2 wrong answers, by the way, so let's actually do plus 10 minutes here. Disappointing. Alright, circular array nums and array queries. For each query I, you have to find the following: the minimum distance between element and any other index j and what? The minimum distance. What does distance mean? Query 0, and nums of 0 is 1. The nearest index of the same y. Oh, I see. And it's circular. Okay. And it's just binary search, right? I don't think there's anything too tricky about it. So something like that, right? And then, so it has to be the same but not dissimilar, right? So then now we just find it, right? So for Q inquiries, F sub Q, we want to binary search this to get the index, and it has to be in there just by definition. So F of Z, is it F of Q? No. F of num sub Q, right? Yeah, okay, so, well, we have to search it for F, okay, we have to search in F of num sub Q. We want to search for Q, because that's the index, and it always has to be in there. Okay, fine, right? So then now it is going to be either, okay, so the index, so it's going to be Q, F of num sub Q of index plus 1 mod length of F of num sub Q. So it's Q, is either this or the plus version. Oh, actually, I guess subtract version. Whoops. And that should be it. What if that's the one value? Okay, if it's unique, then it is not, right? So, okay, so I think I return 0 in that case. So I could just check for that, because if it's all unique, then it should be not 0. So that's fine, but this is actually wrong as well. Why is this wrong? Oh, because it's not doing the circular math. Okay, that makes sense actually. Yeah, it's annoying though. Okay, so this if okay, let's just do the special case first. If length of F of num sub Q is equal to 1, then we just append -1 and then we continue. Otherwise, with binary search, okay, that's fine. I did the wraparound on the circular array, but I didn't do the math on the wraparound, right? So okay, so this is going to be okay. So maybe I do I don't know. Naming things is hard, so let's just go C for calculation. Right, and then now we have C, A, B, right? So then it's either return absolute of A minus B, or A plus length of nums minus B, absolute value of that, I think. or a minus b minus length of nums, I guess. Something like that. I don't know. Right, looks okay. Let's give it YOLO submit. Come on, okay. Could not stand another one. Ooh. Oh, my thing fell asleep. Okay, lap 4:59.74. Okay, good job, Larry. Did not make a silly mistake that time. Oh wait, no, that's not the time. That's the lap time. Okay. Dang it, watch. Okay, fine. We'll just do the math later. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this contest and this problem, this explanation, everything in between. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye-bye.